Hey, good afternoon, everyone, or good morning to whoever it was who was in Mexico. Thanks for asking me here, first and foremost, to come and tell you something about an exciting technology that we're involved with here at Seadrill, and it's to do with red zone management, and it's something that we started working on with another company, the Marsden Group, about a year ago. And it's come on in leaps and bounds since then, from concept to something that we're actually in a position where we've tested it offshore, and now we're just waiting for some of the technology to get certified, and then we will start installing it on a couple of rigs to do further testing and further development of that. So the technology is Lidar, and rather than me talking for the next 3 minutes, I think, Joachim, if we should play the video now, that might be best. Hopefully everybody will be able to see it, and then I've got a couple of slides I can show you at the end.
Yeah, I'll run it now.
Today, technology is advancing faster than ever before, and with the continued development in the Internet of Things, autonomous vehicles, and AI, significant opportunity has been identified to harness these for critical applications in the drilling industry. Managing red zones around the drill floor continues to be a challenge in the industry, especially in operations where the drilling package is manual or semi-automated and people have to enter the red zone for key operations. The Marsden Group, in strategic partnership with Seadrill and empowered by Microsoft and NVIDIA, have been rapidly developing a solution utilizing these technologies. The combination of LiDAR, advanced vision processing, and integrated high-powered edge compute offers a method of identifying, tracking, and predicting movements of people and equipment in complex industrial environments. The technology can be configured to detect, inform, and act. For example, stopping a pipe handling machine if a person is in its path of movement. All with easy installation and no requirement for personnel to wear specific devices. Our early concepts, versions 1 and 2, were refined and tested at the Marsden Houston R&D facility, demonstrating multi-person tracking, dynamic red zones, and wireless streaming real-time into a 3D visualization engine that can be viewed both on the rig and streamed back to shore. The ruggedized V3 prototype was taken for trials offshore for use in real-world environments, both on the drill floor and in crane operations. Based on the success of these trials, the full ATEX certified patent-pending designs are going into production and are being rolled out across 12 of Seadrill's rigs. Covering drill ships, semis, and jackups, this solution will give us the ability to keep our people safe and increase our operational efficiencies.
Yeah. But essentially, yes. So what we've been looking at is using LiDAR technology and its application with red zone management. What's kind of interesting about LiDAR is that it's not a new technology by any means whatsoever. It's 15 years old. It's been used in other industries in various applications, but I think since the increase in the increase in need, I suppose, for the autonomous car, the technology is becoming it's getting better and better, and also it's becoming more and more affordable to something that previously would have only been used on, spacecraft or something like that. So the idea of LiDAR itself is to be able to track the exact location of people and putting that on a rig, and particularly on a drill floor, and understanding where our people are. We've seen many times in the past people getting hurt because they're in areas where equipment is being operated and the person who's operating the equipment can't see that somebody is there. So we wanted to see if there was something out there that we could use. And to be honest, we are looking at several different technologies for this as well. We use artificial intelligence, computer vision in basically the our systems are able to see what's happening on board the rig. Obviously, you have the Lidar, which is like a puck. And then in order to bring all this to life, you have to have something called edge processing, which is basically taking all the readings that are coming off the Lidar, doing everything that is needed to be done on the actual rig itself. So what you don't want to be doing is sending huge amounts of data off the rig, because obviously we're very much hindered by bandwidth. And then you have these advanced visualization models, so whereby we're understanding when equipment is moving, how fast it is moving, and what direction it's moving, and knowing the exact location and movement of people around there, being able to pick them up and being able to say, hey, look, there's somebody here, you need to know about this, or eventually getting to the point where actually you could slow down the equipment or bring it to a stop before it got anywhere near the person who was in the way. So the key features, I think, and that are important for this is nobody has to wear anything. There's no requirement for extra sensors or tags or anything like that. You know, this is a system that you put on board. We think for a drill ship, we would use 3 Lidars mounted in basically forward, aft, and above the doghouse on board a drill ship. And we think for jackups, we would probably do it with 2, although we need to do some more testing for that. And for semis, we believe it is probably 2. It's very easy to install. These boxes, you come out, you put them up, and you switch them on. Now, for the first period of time, they have to learn, and we're using artificial intelligence and machine learning. And one of the most important parts of this is that you put them up there and you allow them to understand what's going. You allow the machines to understand exactly what's going on the drill floor, and then it will recognize equipment and it will recognize people. Now, when you put these on, it's not learning from scratch. Don't get me wrong. You know, we've already for our ones that are ready to go on the drill floors, they've already been programmed to understand the difference between certain things, and absolutely they can already recognize people. But it's just getting them up and getting them moving, and the more time they spend there, the better these models and the better these algorithms get. It's absolutely modular. You know, we take them out, we install, you apply a power cable, and you're pretty much good to go. There's options for control system integration. Now, this is when we get further down the line, but we're still hoping that we can have these conversations next year, towards the latter part of that, whereby we want to be able to integrate this into the system, so much so that if it sees something and something's not right, the equipment is slowed or brought to a stop. The 3D view visible is on and off the rig, so you can, for anybody who's off the rig, they will be able to see, you know, the same sort of screen that the driller is seeing, probably not at the same definition. But if somebody wanted to monitor that from afar, that would be possible. Although at the moment, we're only really talking about showing it, giving it to the driller, letting the driller understand exactly who's around. And probably the final thing, and I think this is one of the most important things compared to other solutions that we've looked at the moment, is it's the idea of dynamic red zones. So the red zone that you have for tripping could be different from the red zone that you have for running casing or running riser, and it's being able to configure that and to set that up how it's required. And the driller can do that on the application whilst he's sat in the chair. So as things change, as the operations change, he can put that in. That gives us a lot more understanding and a lot more control of exactly what's going on board our rigs and on our drill floors. So the actual Lidar modules themselves, these are some kind of mocked up versions of what the latest version looks like. You'll have seen in the video, there was the ruggedized version. That's now come along a long way as we've kind of further developed it and added more technology to it. And also we're in the final push now towards our ATEX compliance, which will be a huge part for us. And then once we've got that, we will start installing these on board our rigs. So the actual Lidar modules themselves, these take about 2.4 million readings per second. So if you can imagine, they are scanning literally absolutely everything. And these are giving you, because it's Lidar, and Lidar is essentially a combination of, I suppose, laser and radar. It's probably the easiest way to think about it. It's giving you a very accurate understanding of where everything is. We also use cameras. So we have 3 cameras on the latest units that we've seen. And the idea of the cameras is if the Lidar sees something that it's not necessarily sure about, we have a backup system and these are constantly talking to each other. Although they are separate, they, you know, if the Lidar's not sure, it would say, hey, what's this? And the camera will go, yes, that's definitely, you know, that's a tongue, for example, if it's unsure. And we've seen we've tested this, and the actual time taken for that question to be asked and for that understanding to be had is like 0.01 of a second. So it's happening in real time. One of the other reasons is that we have the cameras as a backup system, but it's only as a backup system. Is that what we found is that when testing cameras offshore is that you tend to lose them at certain times of the day. They're a lot more susceptible to light and change in light. So for example, at dusk and dawn, when it's very bright and the sun's very low, you can lose the cameras. And also, certain weather conditions and whatnot. What we found with the Lidar when we tested that is, obviously, it's laser. It sees through everything. It's sending laser out and it's bouncing the signal back. To modular installation, I've already touched upon the ATEX EX certification. We're undergoing that at the moment, and we expect to get this done. I think we are looking at mid Q1 that'll be finalised, and we're ready to go. The solution that we're looking to employ in Seadrill is a wireless solution. We're fortunate enough that we do have industrial Wi-Fi onboard our rigs, and also that we have the right architecture in the background that would mean that we would only have to supply a power cable to these units. Now, for any other company that we're looking to invest in this or to trial this, it would depend upon your setup. Some of you may want to run just regular Ethernet cables, or come up with your own solution for how you would get the data to where it needs to be and get it processed. And you can also have camera-only options for focus zones, and also you can actually tie in on the cameras that are already existing on the rig floor, should you want to do that as well. So finally, it's kind of our application. So at the moment, we're focused on using this for the red zone, just monitoring where people are, understanding what they're doing, and making sure that no one is in danger. We want everybody to go home safe from their hitches. But the next step after that is, moving into anti-collision. When we integrate this with our current systems on board and actually are able to affect the movement of the equipment. There's more applications that this technology can be used for that are not necessarily in terms of a red zone management technology, and that would be, for example, operations performance. Because if you imagine, these are seeing absolutely everything that's happening on board a drill floor. So these will subconsciously know if you're tripping, if you're running casing, if you're running riser, based on the movement of the equipment and what they're seeing. But also we see a great opportunity here for crane operations, and it could either be used in things like evacuations and security, making sure that everybody on the rig is in the right place at the right time. It's a very exciting technology. It's something that we've as I say, it's moved on very, very quickly, and we've developed it very, very quickly, and we're really excited about the direction that we're going in here. But one thing I think that is very important to point out on this as well is this is something that we've been developing with the Marsden group, and also working with Microsoft and NVIDIA, as the video alludes to. But this is not something that Seadrill is looking to have any form of exclusivity deal with. This is something that we want to put, we want to see out in the market. If this is something that is going to keep our people, keep people safe, excuse me. Sorry, bang there. If this is something that's going to keep people safe offshore, we want this to go to every rig, to every company. So we have no interest in exclusivity or anything like that. And if we know that Marsden's been speaking to several other drilling contractors about the opportunity, and we encourage that. The more rigs this will get on, the better the technology will get, and the safer everybody in our industry will be. So that's kind of it in a nutshell. If anybody has any questions,